Hello guys, and then welcome to another video. As we've already stated earlier, we'll be just going through current division rule, okay, and then we might dive into voltage drop calculations. Okay, so let's just dive right into this video. So in case you are new here, kindly subscribe and then hit on the bell icon so that you don't miss out on any uploaded video. Okay, so let's just dive right into it. Okay, so this tutorial video will be very concise. Okay, so we'll be talking about current division rule. Okay, so that's we are trying to find current in every node. Okay, whenever there is a node and then there are some branches, okay, where the current divides. Okay, that's where we have a current division. Okay, so from here we have I. Okay, so the current is coming from this voltage, the positive terminal, okay, coming from here, and then it will pass through here. When it gets to this node, it will just divide. Some will just pass through R1 and some will just continue and then pass through what? I2. Okay, now so all you are trying to do is just find a current which will pass through this resistor and the other current which will pass through the resistor R2. Okay, so without further much ado, let's just dive right into the calculation aspect. Okay, so now this is how you find your exact formula for calculating the current division for a specific current, that's I1 or I2. Okay, so let's just dive right into that. Okay, so now since we already know the formula for finding total resistance for parallel resistances, okay, we will apply the same principle over here, because we know that once we traverse through this circuit, we could notice that R1 and R2 are in what? Parallel. So in case you don't understand what I just said, kindly go back to our playlist or just find a video in the description and then you go through the parallel and then series resistance and get to understand what I'm trying to say. Now let's dive right into this. So we know that our total resistance, okay, total resistance will be what? The R1, okay, multiplied by the R2, okay, and then we divide by the summation of the two, okay, R1, okay, plus R2, right? So from here we know that there is something we call the Ohm's law. Okay, the Ohm's law will show you that once you multiply the current with the resistance, you get what? Voltage. But there is a simpler method of remembering this. Okay, all you have to know is that respect is very important. That's what you have to know. Okay, we know that respect, okay, is what? Very important. Okay, so respect is very important. So in the same manner, you can just simplify this as V, okay, equals what? IR. Okay, so R is the respect, V is very, and then I is the important. So respect is very important. Okay, and then you just simplify this. Now this V equals IR is what we call the Ohm's law. Now since we know that this R is equal to the total resistance, we can just write that over here. Okay, so this will be our RT. So we have what? V equals what? I multiplied by what? RT. Okay, so now we have what? I. Okay, we are just substituting RT with this, okay, into this expression. Okay, so we have what? I multiplied by what? R1, okay, R1 multiplied by R2, okay, divided by what? R1, okay, plus R2, right? So now let's both on. Okay, so now we have what? This simplified expression. Okay, now let's break this further down. Since we are trying to find current division, okay, so we are most interested in current, all we have to do is just make the current the subject from here. Okay, so now since we know that I, okay, since we know that I is equal to just what? V on R, okay, V on R. That's this expression, okay? So you can just substitute that, and then we'll get what? Once you simplify this further, you end up with what? I, okay? I will multiply R1, okay, on R2, okay, divided by what? R1, okay, plus R2, okay, all divided by what? R1, okay, this R1, this R1, okay, so we have what? R1, right? We just substituted. We wanted to find the I1, okay, so that's what we just did over here, right? So now let's simplify this further, okay? So we have what? I, okay, multiplying what? R1, okay, multiplying R2, okay, and then you divide that by what? R1, okay, plus R2, okay, and then you multiply that. See, when you take this one upwards, it will be what? 1 over what? R1, okay, so we have what? 1 over R1, okay. So once we simplify this further, this is still what? I1, okay, don't forget that this is still I1, okay. Okay, so note that this V, okay, and this I is just this, okay. That's why we simplify this into this form, okay, and then divide that with the R1, okay. So the entirety of this, okay, the entirety of this, okay, was this, okay. The same applies to this, and it's the same thing over here, okay, and then we just divided that by this R1, okay. Yes. Now let's just continue, okay. So now after simplification, this will cancel that, okay, this will cancel that, right? So we'll have what? We have our I, okay. In its simplest form, we have our I, okay, I, right, to multiply R2, okay, divided by what? R1, okay, plus R what? 2. Yes. So from here, you could notice that we've been able to arrive at our current, okay, for what? I1. We could do the same thing for I2, okay. So for I2, you just have to just substitute that, okay. So we have I, okay, R2, this R1, okay, divided by R1, okay, plus what? R2. Now let me show you the simple approach. So to get this, all you have to do is just use the current division rule, okay. In our simplest form, that's what we are trying to prove, okay, using the current division rule, okay. So now this is the trick you need to know, okay, without going through the proof and stuff. This is the only trick you need to know. Once you are looking for this I, okay, you concentrate on this, okay, just concentrate on the R2, okay. Once you are looking for I, concentrate on R2, and then once you are looking for I2, concentrate on what? R1, okay. That's how it works. So once you are looking for I1, just concentrate on I2. So that will be what? Once you are concentrating on R2, it means that R2 will be your what? Numerator, okay. And then once you are looking for, or you are finding I1 or I2, means that R1 will be your numerator, okay. So once you are looking for I1, okay, since you are looking for I1, R2 will be what? Your numerator, okay. Then divided by what? R1 plus R2, okay, and then you multiply that by the main I, the main current flowing, okay. So this is what I1, okay. You multiply that by your main current. The same applies to I2. So once finding I2, you concentrate on what? R1, okay. Concentrate on R1. So you have what? R1, okay, divided by, okay, you have what? R1, okay, plus R2, okay, and then you multiply that by what? The main current flowing through. Okay, this is a simplified form, okay, the simplified expression, okay. This is the simplified form of the current division rule, okay. Yes, so we will be applying the same thing in this example, so kindly follow me and then you get to understand. Okay, now, so we have a certain voltage with current 10 amps, okay, and then it's placed over here at the node, and then it passes through the 3 ohms, and then we have a 2 ohm resistor and then another 2 ohm resistor. So in order to put this entire circuit into this format, okay, we need to first find the resistors which are in what? Parallel, okay. And then from our previous lesson or tutorial, I got to know that this will be in what? The 2 ohm will be in parallel, okay, with the 2 ohm, okay. So let's first find that. So that 2 ohm will be in parallel with 2 ohm, okay. So that will give us what? 2 by what? 2 on what? 2 plus what? 2, okay. And this will give us what? That's 4 on 4, that's what? 1, okay. So you have what? 1 ohm. Right, now this circuit can be simplified as what? Into this simple format, okay. So we'll just have a circuit like this, okay. Right, simplified circuit, okay. So you have that, and then we will just represent this over here, okay. Right, as simple as that, okay. So you have a current, okay, 10 amps, okay, and then we have what? Current I, okay. So most definitely you have another current over here, that's what? I2, okay. This I2 and this what? 1 ohm, okay. And then we have what? 3 ohm. Now let's calculate for the current in what? The current division in I1, okay. So from our previous formula, we got to know that I1 means that we are concentrating on this one, okay, on this resistor, and then I2 means we are concentrating on this what? Resistor. So we have what? 1, okay, divided by what? 3 plus 1, okay, multiplied by what? 10, okay. Right, so this will give us what? We have what? This by this will give us what? 10, okay, and this will give us what? 4, okay. So this is 10 on 4 amps. You can just simplify this further to get what? This is 4, that's 2.5 amps, okay. So you could do the same thing for what? I2, alright. So we have what? I2, okay, will give us what? So I2, so our concentration will be on what? 3 ohms, okay. So we have 3 on what? 1 plus what? 3, okay, and then you multiply that by what? 10, okay. So you get what? This by this will give us 30 divided by what? 4, okay. So this will be 31.4 what? Amps, right? So we could notice that these are simple calculation for what? Current division rule. Now let's dive right into voltage drop, okay. This is very, very simple. So once you go through this, you will get to understand, okay. Now let's dive right into voltage division or voltage drop calculation, okay. Yes, now this is our voltage drop calculation now. Okay, so again from Ohm's law, respect is what very important. Okay, respect is very important. This is the same as what V equals what IR. So this is our what Ohm's law, right? This is our Ohm's law, right? Now, so for voltage drop, it means that the summation of all the voltages must be equal to 0. Okay, that's what voltage drops mean. Or in simple terms, once the summation of this main voltage must be equal to this, okay, or this must be equal to the summation of this, okay. This V must sum up to what V1 and then V2. So what I'm trying to say is that once you sum V1 and V2, they must be equal to what the main voltage, okay. So this is what I mean. So we have V, okay, must be equal to what V1 plus V2. This is what we mean by what voltage what drop calculation. And then note that we already know that V, okay, is equal to IR. So this can be simplified as I1 R1, okay, plus I what 2 R2, okay. Yes, it's as simple as that. And then you can just do some algebra, okay, change of subject and stuff. So maybe let's make V2 the subject from here, okay, from this expression. So we'll get something like V2, okay, equals what V minus V1, okay. Same applies and the other way around, okay. So now let's apply the same principle over here, okay. Yes, so let's find the current, okay. We are trying to find this current, okay. Let's find this current and then this resistor, okay. So now, so the first thing you do, you just use your what the Ohm's law, right? We already know this, okay, right. Now, and then we already know the voltage drop calculation, okay, V1 plus V2, all right. Now let's see what we can do over here. So we know that V is the same as IR, right? So all we have to do now is to just insert our values, okay, and then we will arrive at what we are looking for, okay. So now we know that V, okay, is what IR, but we don't know I, okay. We don't know I, right? So all we have to do is to find our I, okay. So we have what V equals V1, okay, plus V2, okay, right. And then from here we know our voltage, okay, and then our what, we don't know our what resistor, but here from here we can just find our current from here, okay. But before we do that, you have to know that the main objective of this voltage drop calculation, okay, is to use our voltage source to find our missing variables, okay. Yes, so we can just start from here. So from this Ohm's law, we can just state that V is equal to what IR, right. And then from here, okay, from here we could find our what current, okay. So we have current is equal to what V on R, right. So that's what 6 on what 3. This is what we are looking for, okay, our current, right. So we have 6 on 3, that's what 2 what amps, okay, that's 2 amps. Now since we know the current, we can just find what the resistor over here, okay. Now so from the same principle of Ohm's law, we can just find out what resistor, okay, R equals what respect is very what important, okay. Yes, your guess was right, just like mine, okay. So now you could notice that we'll just find out what resistor from here. So we have what? The voltage to be what? 4, okay, divided by what? Our current. Our current is what? Yes, our current is 2. So our resistor is what? 2 ohms, okay. So in order to verify our answer, okay, you'll notice that whenever we add this 4 volts to 6 volts, we will end up with what? 10 volts, right? Whenever we add 4 volts to 6 volts, we will just end up with what? 10 volts, okay. So I hope you enjoyed this video, okay, and then I hope you implement this method and then you get to understand this as simple as that, right? So in case you enjoyed this video, kindly subscribe, kindly hit on the bell icon so that you don't miss out on any uploaded video, okay, and then like, okay, and then share, okay. Subscribe, hit on the bell icon, like, and then share, and then you can also share your comments with us in the comment section below, okay. So in the next video we'll be talking about Kirchhoff's rule, okay. That's where we'll be using the Kirchhoff's current and Kirchhoff's voltage rule, okay. So I'll see you in the next video. Bye bye.